So everybody's math and science and all the technology mind parts got activated. So let me quickly kind of take it forward from where Ranjan left. There are a few things that Ranjan mentioned during his conversation and his presentation. If you caught on some of these things, then I'll kind of be building upon it more from an industry and a business application point of view, right? How everything that, or a lot of what he was talking about, how does that get applied in real world in today's business scenarios? I'm the CEO founder of Pluto 7. We are one of the handful of partners that Google has selected to implement machine learning and AI for some of the most Fortune 50 companies or Fortune 500 companies and so on. So what I'll be really sharing here is the practical example of implementation of a lot of what you just heard. If you keep in mind a few things that Ranjan highlighted, which is artificial intelligence is really an extension of human-like thinking, right? And a lot of what if I look at the content, what Ranjan shared, and if I look at my college days, where some of it were discussed during, then I couldn't really relate how it gets applied in business, right? Today, I'm in a stage where myself and my team, we are using a lot of these concepts, right? And on a weekly basis, we are working with customers to improve taste of beer, to handle cyber attack situations, to solving very, very mundane things like, expediting, hospital approval so that people are operated faster, to broken bones. I can go on with a long list of all the applicability, and these are not sci-fi, right? This is happening today. Companies are doing it, and they're innovating. And to other point that Ranjan mentioned, which is around if we spoke about internet in 1995 and how internet impacted the world, it would be a little hard for most people to imagine. And today, if you talk about this impacting the world, it's still a little hard for the broader audience to imagine, right? And that's okay. That's part of why we are the smaller group here, are here to think ahead of the industry. So before I continue with my presentation, I just want to highlight a few people who I see. Karpakam, who is my partner in crime, she has helped me with set this up. So Karpakam, if you can just raise your hand or stand up. So thank you. Right. All right. So, all right. So let me see. So I won't take too much of this time. So essentially, I've been working with Google for a few years now, and my daily job is to listen to customers on what they want to solve or what they think they could be solving, and build machine learning model with my data scientists and engineers and so on. So that's in short what I do. So if you look at the TensorFlow board and all those things that Ranjan was sharing, some of it, if you look at Google products and what Google has been doing, pretty much machine learning and AI is used everywhere, from your Gmails and photos and so on. The good thing about today's event, you'll be hearing not only about what Google has been doing and how we are applying that in industry, and you'll get a flavor for it, but you'll also be hearing from IBM, from Microsoft, and how Facebook and all these different companies are adopting it. So quickly, if you think about what Ranjan was mentioning, human-like thinking, right? If you have to determine whether it's a cat or a dog in that basket, our natural way of thinking is what is the basket? So it has to be something in a house, and within the basket there is some clothes, so it should be a laundry basket, and within that there is an animal. Is it a cat or a dog? And then basically you're doing an image recognition, right? And the TensorFlow board that you are playing with, and it's the concept of whether you're looking at an image or doing a time series forecast or predicting sales, the fundamentals are the same. So it's and when you start applying to business use cases, it's mind-boggling in terms of how retail companies, and we deal with some of the largest retailers who want to compete with Amazon.com, so on how they plan to use AI, or they're already using AI. To just go back, so one of the common questions that I get asked, and I'll go through a few of the industry examples, and I'll also have you at least log into a system depending on, and by the way, logging into a system in this session is optional. There are other sessions coming up later in the afternoon where you're encouraged to log into systems. So when one of the common questions I get asked is, hey, we have all kinds of technologies, we have all kinds of BI, how is machine learning different, right? BI primarily, and I'm trying to generalize that, but BI primarily starts off with a bias, right? Which means filters, rows, columns that you select, versus here, you're really going about mimicking a human brain and avoiding these biases, right? And I've been doing this predictive analytics and forecasting for 17 years, including doing for some of the biggest companies here in the Valley. And so it's always like a human trying to draw the boundaries. And why did the human draw boundaries around how forecasting should be done or how planning should be done? It's primarily around compute and memory capacity. You couldn't just let a computer run on its own and keep practically infinite computation or something like that. So you kind of put some biases, introduce your bias in the name of experience and so on. Net is you end up with lower forecast accuracy, right? And if you think about these human decision making, right, it's whether, and I'll give you some examples of a brewer who has been brewing beer for 30 years. He stands up in front of this is the largest brewery in the world, stands up in front of his executives and says, I can beat this machine, right? Machine learning model. It makes better decision than me. And he has a 30-year experience in it, right? Their C-level executives are shocked, right? And it is that realization when Ranjan was talking about the Go, not being able to beat the Go. And by the way, people have been playing that game for 2,000 years. And machine beat man for the first time. And 40 million people play this every year. So it's that realization that there is no point trying to beat the machine in certain areas, and we should accept it. And there are areas that are still rule-based and other systems have its place. It is that realization is what separates when you should use or should you not use machine learning and AI. And when it comes to these problem solving, right, it's really this paradigm shift, right? You're sitting in Silicon Valley. Today you're hearing from some of the guys who are solving the problem, representing pretty much the whole world. And the difference is, okay, if I have all this BI report and all the analytics of upsell, cross-sell, customer segmentation, and so on, why do I need machine learning, right? So my simple example is, forget about all the complex math and everything, right? If you ask your guy to do a what-if analysis, how long will it take? On a complex scenario. He said, yeah, it takes about 2 hours and he'll get me the results. Ask him to do it every 5 minutes throughout 24 hours, and let's see what happens tomorrow. That's it, right? So there are things that you need to think about, like it's just like, asking this guy to carry 2,000 bricks up the building. It's impossible, right? At least in a given hour. The point is you have to start thinking like this, that you have a mechanism that will really take it to the next level. So, and in industry, that's actually one of the bigger challenges that we're facing, right? So some of us are fortunate that we can get deeper into the subject. Many times C-level executives who are making these decisions don't have the time to sit and understand this at a greater depth. I have C-level executives who sit with me and my team and with Google to spend days together trying to understand what's the real deal here, right? So, and this is happening at a very, very interesting pace. So I'll give you some examples, and I'll also quote what deep learning model was used behind it, right? And then you can go and do additional research, and then, of course, during Q&A, we'll talk about it, right? So the first example is improving the taste of beer. What has beer got to do with machine learning, right? The taste of a beer is literally determined by how you look at the beer and see if there's any the turbidity or what's in the beer, and it's a visual inspection and determining what's on 2 or 3 gauges coming out of the big keg or filter when the filtering happens. Now, the person pretty much relies on three gauges, and he reads through that data and he says, beer is good, beer is bad. His accuracy level is 60 to 70%, which means 30% of the time he's wrong. He's the most experienced person, and he's wrong 30% of the time. You're wasting beer, you're slowing down beer production, and the quality of the beer is not consistent.
How are you judging right or wrong?
The right or wrong, first of all, I'll tell you the traditional way, and I'll tell you the machine learning way. The traditional way is literally beer inspection, tasting, and looking at certain gauges. So that's right or wrong.
And it tastes good or bad?
It tastes good or bad, it looks clear or not clear, and the gauges look okay, and so on, right? Now, there are three gauges. Now, what they didn't realize is they have three gauges. Think of it as three features or three columns in your Excel spreadsheet, just for simplicity. What they didn't realize is they have 200 such columns, right, or features that they could potentially explore. We go with a small team, and essentially, and I'll talk to you about the model in a second. We go with a small team, and we essentially say that, hey, we're going to run a machine learning model. We're going to find which ones are significant and come up with a better accuracy. And it turns out that they were expecting us to beat by 10%, and we beat by about 23 or 30%, right? And that was shocking to them that at that point, the person acknowledged that I can't beat this. See, it is this, and this is just one example. Like this, there are like 10 or 20 examples I can give you. It is this realization that we cannot beat the system, and when it's designed right, right?
So, by the way, what do you mean by system? System is, end of the day, people, right? The
Correct.
People go through the same experience.
Correct.
Just to manufacturing.
Right.
As a beer drinker, I go through the same visual, same experience.
Correct.
I am still 30% wrong as a
Yeah.
customer, right? So
Right.
what is your 23% comes from?
So the 23% really is selling that if there are the beer quality, when the machine says the beer quality is good, it's actually good. Now you can take the sample of the beer and you'll say it was actually good. 8% of the time it can be wrong, right? So that's really what the difference is, right? See, the thing is, the beer is good or not good. It's not just about look and taste. There are a few other elements that they determine. Machine, when it's said it is good, it's actually good, right? So when through those tests, if it says the beer is bad, you have to throw the beer. So which is a pretty significant.
I understand your point. So how that 23% is translating into revenue, right? As a beer drinker, I'm still making 30% error.
Correct.
Right? So that is not impacting a customer.
So the revenue, I will give you a broader answer because this is a pretty deeper question, and during the evening I will explain it to you a little bit more.
How does it translate to revenue, right?
Okay, revenue translation, this is agreed by the CFO of the brewing company. They're going to save $50 million every year, US alone, not worldwide. What's that?
From throwing out less beer? Is that
Yes, throwing out less beer, not disrupting production, saving labor hours, filter costs, there's a whole bunch of things. So all comes out of one machine learning model. Go ahead.
Just to be sure about this, so what you've done is optimized good or bad
Yeah,
based on research that was done with customers,
correct.
as opposed to saying, let's put this beer in front of 50,000 customers and say what they think is good or bad.
Yeah, so let me clarify this for you, right? Doesn't go out of the manufacturing floor. This is all in-house, right? It's like the in-house determines whether the beer is good to go out in the market or not.
Yeah, but the definition of good or bad
Yeah.
has been based on some human research that's been done out in the field.
In the plant. This is nothing to do with the beer. So the beer is brewed, and it comes out of a filter, and it's bottled. It is the filter replacement. Okay? The machine learning is saying replace the filter or don't replace the filter. I'll go through this more in detail. So essentially, the machine model said filter is bad, replace it. Otherwise, the beer is going to be bad. Okay? If you don't replace it, you have a lot of wastage of beer. Preventive maintenance, if that's the term that is understood more. Yeah.
I just wanted to make a follow-up comment to Gentleman's
Sure.
statement here. So when you were talking about a consumer being 30% wrong potentially, that could be one person. But when you are taking a larger population of all beer drinkers, you are bound to get a more accurate assessment of whether the beer is good or bad. Now, in the plant, there's only one or two people who are making that call. So they can be wrong 30% of the time. But when you take the overall population
Correct.
rather than machine learning models.
Yeah. So for the companies, right, they need to be sure that they're shipping out the right product, right? That's a big deal. So like this, there are examples after examples, right? So all of you have these phones and there are sensors. This is not made by Apple. This is made by another company. When we walked in, they said, we have been doing this business for 30 years. What machine learning model are you going to build? And in our, we are already 20, 30, 35, 40% inaccurate. We are a semiconductor company. So in 6 weeks, we built a machine learning model and we beat 8 out of 10 times, right? Our model is more accurate than humans 8 out of 10 times. Humans are only accurate twice. Now, this hits them very hard. So you're saying that I should be firing a whole bunch of people, right? That's not what I'm saying. I'm saying use your people's brains for better purposes, not for looking at 10 years history and so on. There is no way he's going to look at 10 year history and accurately predict your next smartphone chips and so on. So, and these kind of implementations go on, right? Like if you wonder how Amazon always delivers on time and price optimization and so on, there are tons of machine learning models behind it. There's a question in the back.
You mentioned 200 features.
Yeah.
Where did they come from?
So the plant has many different, as the beer is getting processed and from various stages of raw material, they're capturing information like heat, pressure, all kinds of information over a period of time and before it gets to the bottle. And those are all captured in their ERP, but they never thought that is relevant to the beer quality, not all of them. At least they thought only some of them are relevant. So the real significance of solving these problems is combining math, your domain knowledge, and technology. That's really the power here, right? So, and then if you look at what's happening around in the business, now companies are looking at it from like, and if you think about why are C-level executives reaching out to Google and Microsoft and all these companies and solving this, because they know this is happening or is already happening and it's coming, right? Ranjan mentioned about doing all of this through a platform, right? And for when we start doing these projects, usually they start off with, okay, this is sci-fi, this is not for us, and so on. So I'm going to quickly show you the platforms. During the later part of the day, you might see other platforms as well. Keep in mind, there are multiple platforms available, including open source platforms. We happen to be the one, when it comes to Google Cloud, we are more familiar with this. We started off with AWS. AWS also has a lot of different options for what I'm showing here. And so it's if you're not familiar with Google Cloud, it's an equivalent of AWS in simple terms, right? So what I will show you here is some of the things that Ranjan spoke about and how we go about building the model, deploying the model, managing the model. I'll only go through a few elements here, and you can try it yourself. It's cloud.google.com. So there are a few things that Ranjan mentioned, which is wrangling data. Then you need to do feature engineering, and then you build a model, and you deploy a model. Through our experience, I'll highlight a few things, and then during the Q&A session, I'm more than happy to answer more questions. 70 to 80% of our time when we build a machine learning model goes in just gathering, preparing, and getting the data ready for building a machine learning model. Only 20% of the time goes into actual model building and fine-tuning, selecting the right RNN, DNN, and all these models, right? And it's so what essentially you end up doing is you first get the data into some central repository. Let's say if you're doing forecasting, time series forecasting, you're trying to forecast. Let me show you the output first so that you can hold off on trying to analyze this graph too much, but I'll just give you the answer, because then we'll end up with a good debate, and we have only 15 minutes. Essentially, what we are saying here is, I can walk because of the mic. So if this is today, humans, if I asked them 10 weeks back, how much are you going to sell? They told us 1.2 million. And they kept stuck to that story every week and until today. And the actual shipment, when it happens, it was 220. But while we are asking humans, we also ran a machine learning model predicting what will happen today. And if you look at it, the machine was more conservative than humans, which is red, and shipment, the real shipment is this blue line, which it drew backward. So, which means machine was accurate all along or closer to the blue line than humans, right? Now, this is not one trial. This is like this. We ran 10 or 15 trials before the human said, I can do this on my, I can't beat the machine. The point is, when you come to this realization, how you run these models and how you adopt in your business changes your organization structure. Now, how do you start off with doing this, right? In a platform like this, first you have to get a data. Your data could be in CSV files, flat files, and in this case, I'm just going to show you a simple input file. There were questions. We are talking about training data, test data, and you see the files over here. For people in the back, you can see it. We'll see if we can send you some screenshots later. So essentially, you have your input data, what you uploaded, right? The input data could be simple shipment history, last 10 years, right? And all related information. Based on that, you're predicting how much you're going to sell in future, which is what this graph was showing. So once you store your data, then you need to be able to wrangle and massage the data and so on. So then there's a corresponding tool, BigQuery, for this, and where it's runs 30. You can query 100 billion rows in 30 seconds. This is the same platform that Google search engine runs on. So essentially, you'll prepare the data, you query, and so on. And then at this point, let's say you've prepared your machine learning data for your machine learning model. One of the things that we have come, we believed customers will come to this realization, and we are starting to see that, which is most customers that we see start off building machine learning model on-prem and eventually realize that they run out of capacity, scale, and staying up to date with the most latest algorithms and so on. And then eventually they move to one of the public cloud platforms, the AWS, Microsoft, Google, and so on. So, and part of the process is to take your machine learning model and put it in an environment like this. So what you have here is a model that is deployed. When we say model, keep in mind, for some of you who feel like they are relatively new in this area, it is really mimicking a human brain, right? There is a role called demand planner for the forecasting that I showed you earlier. There is a role that person makes a decision, right? They run statistical model, but they also decide finally how much you're going to ship every month, which means how much you have to stock and so on. The way we go to design a machine learning model in those companies is we start off with really understanding the person, right? Understanding what he does, how he does, finding out what is the weights, as in, what does he give more importance to, what's the bias, right? It's like, you can call it his experience, whatever, right? He's biased towards a certain set of product lines or customers and so on. And then you determine that you figure out that, the forecast is inaccurate because of these things, right? But you don't necessarily tell them on their face because they're not going to listen to you, right? So you take that knowledge, what you gain through interviews, right, and conversations, you look at the data, you run the model against those, let the data pattern tell you what the real forecast is, then correlate it and explain the machine model outcome, right? So for that, whatever you understood by learning about the business, you define that into a model. And that model is defined and deployed, right? For the sake of simplicity, right, a model is nothing but a mathematical equation, right? There is nothing else in the model. Y is equal to mx plus c, or whatever your equation is, and Ranjan showed a whole bunch of equations. It is really that equation that you're storing. But this equation could be at a product, at a customer level, product customer level, or a various dimensions combination level. That's really what your TensorFlow is helping you with. That is what you're hosting here. Now, you want this forecasting to be done every hour, every minute, and you have these recommendations like how you go into Amazon, whether it's a classification, customer bought this, do you want to buy that, or do forecast predictions every minute or every 5 minutes. You're deploying the model and you're running the model. That's what these models are doing, right? You're deployed it, you're training it, you're running it, you're making prediction calls, and so on. So the platform allows you to do this, right? So why this is important is, the analogy I'll give you is, it's one thing to build a train, and if you're familiar with the Bay Area, the BART situation where they're trying to extend it to Milpitas and so on, the tracks have been there for like, God knows, how many years now, 4 or 5 years. But the train is not still active, live, and running, because when you go into deploying production scale models, there are a lot of things that you run into, right? 9 out of 10, I would say like 95 out of 100 today are pilot production. They're not production ready machine learning models, even if it's being built in enterprises today. Because there's a lot that goes in making sure that these models work with the process, with the people, and everything else. So when we end up going and deploying these models, we have to understand the business process and all of those things. So that's quickly about deploying the model and the platform that does that. I'll give you a few more data points, and then we'll probably have to. So let's hold off on a few questions. So I'll cover the topics, then I'll bring up, open up for questions. Okay. DNN model. Now, you'll hear a few models, and this is all the practical implementation of that. When we had to come up with those accuracies, we used a DNN model. And essentially what we did was, we took the data from the ERP, we transformed the data, we built the machine learning model using DNN, and then it's not one model, right? You try different models to see which one actually works. And then you try out different models, like in the case of deep and wide model, when you're trying to recommend something, when you're trying to rank and so on, using these models, eventually it boils down to a single line of code or one call. Like if you see DNN linear combined classifier, it gets to that level, and then there are standards that these platform providers recommend. Like for example, Google has something called an estimator API. If you use that API and if you call these models and so on, you don't have to worry about distributed computing, as in how many nodes and how many clusters you need to run underneath it, because you don't know, today you might run it against 500,000 rows, tomorrow you might want to run against 50 million rows. You shouldn't worry about performance and so on. These are very practical problems when you try to do it on premise, right? So now, few other practical examples, right? I was in Florida a couple of weeks back, and this is the largest healthcare provider in US, and their biggest problem is diabetes, right? How can I predict when a person is going to get diabetic? Not when he already has it, when the doctor has said that. And here you talk about machine learning, analyzing patient history, trending towards becoming diabetic. Patient is not complaining, doctors are not have not detected. How can machine learning do it, right? So these are all, you can call it preventive healthcare, right? So, and
I'm from Florida. I work in health insurance.
right,
For health insurance industry or
you're pretty close. I can, for NDA reasons, I can't tell who. Now,
insurance versus hospital report.
it's not hospital, okay? So, and within that, there are multiple players, right? So essentially, when you look at it, right, so you look at a lot of information about the patient, right? And you figure out, like sometimes there are 200, 300, 400 attributes about the patient through internal and external sources. Then you figure out, which model works, and then come up with a prediction that this patient is going to get diabetic over a period of time. A lot of the signals may look okay now, right? But if you leave him on his own, based on all the trends, he's going to get diabetic. Now, now you start getting crazy, right? Once you prove the model that it all works and so on, now they're like, okay, can I embed a chip in his neck and write it into the cloud and so on, right? Of course, these are all things that they want to plan for 5 years, 10 years later, right? Today, humans are not ready to put a chip in their neck. But maybe, once I prove that you're going to live 10 years longer, you'll enable me if it doesn't bother you with a simple operation. And there are certain medical situations, not necessarily with diabetic, where patients are ready today because they know that if they make a mistake, they will die, right? So anyway, so there will be a lot of sessions that you will have later this afternoon. If you want to try hands-on along with some of the speakers, I would suggest, open a trial account. You can close it at the end of the day. It's the trial. If you go to cloud.google.com, it says trial somewhere on the middle, and you can go ahead and do that. So, and by the way, following through that session, is optional, but I encourage you to do that because then you understand the process of getting the data, wrangling the data, and understanding how this whole models work. With that, thank you, and we'll be available during Q&A, and also, if there's anything in between break and so on, feel free to ask the questions. Thank you.